Hi everyone! In this video, we will solve three variable systems of equations. Solve the system of equations 2x plus y plus z equals -4, x plus 3y plus z equals 1, 3x minus 2y plus 4z equals -23. This might seem a little daunting at first, but we're going to take it a little at a time, step by step. And the first thing I do is try to keep these as organized as possible. So I like to label my three equations as equations 1, 2, and 3. And I circle those numbers so that they don't look like a coefficient out in front of the equation. And then I'm going to pick one of these variables to get rid of. And so I look at all three equations and I see, do I want to get rid of the x's, the y's, or the z's first? And it doesn't matter. You can pick any of them that you want to get rid of, and it will always work out to be the exact same. In this case, I like to look for numbers that or variables that have a coefficient of a 1 out in front. The z's have 2 that have a 1, and the x also has a 1 out in front, and the first equation, y also has a 1. So really, it doesn't matter whether I pick x, y, or z. I have an easy way to do it. I'm going to go ahead and pick x just because it's out in front, and again, you can pick anything you want, and I'm just going to mark right here that I am choosing to get rid of the x's, just to remind me that I'm always having this goal to get rid of the x. To do this, I need to make a combination of two equations and find how I can multiply the equations by a variable when I add two of them together that I can get rid of one of the variables. Since I picked x, I'm going to use the variable or the coefficient in front of the x on equation number 2 to my advantage. Because it's a 1, it makes it easy to change and make it match either equation 1 or equation 3, and we're going to do it twice. So I'm going to take equations 1 and 2, and I'm going to label them as 1 and 2 with some circles. To make the coefficient out in front match, equation 1 has a 2 in front of the x. So if I take equation 2 and multiply it by a 2, then the coefficients will match. But I do want one of them to be negative, so that when I add them, they will cancel out. So I'm going to multiply equation number 2 by a -2. And I notate it like this, putting a -2 in front of equation 2. That's my reminder that I've multiplied equation 2 by a -2, putting the resulting equation here. Sometimes as we get going, it's hard to go back and see what calculations did I do. So it's really important to keep things very organized. And that's one way that I like to keep it organized. So I'm going to multiply equation number 2 by a -2. And I'm going to notate that here just a little bit so that you can see that I'm going to do -2 here. I don't do this on my own paper often, just because it kind of makes it messy, but I want to make sure that I get every single term multiplied by that -2. If it helps you to see that, go ahead and write another step. I'm just kind of limited on space on my paper here. So I'm just showing that we're multiplying every single term by -2. So as I multiply by -2 using the distributive property, I get -2x minus 6y minus 2z, and this is the part that might sound kind of silly, but so many people miss multiplying the right side of the equal sign. Don't forget, every single term means every single term, including the right side of the equation. And equation number 1, I didn't change anything on it, so I'm going to keep it just as it is. So we have 2x plus y plus z equals -4. And you'll see as I write my z's, I put a cross through the middle of them because they look very similar to my 2's. If that's something that you have found, it might be helpful for you to also cross your z's. Now I'm going to add these two equations. This is called the elimination method or the addition method, depending on the author of your textbook. And we have 2x minus 2x. These cancel, and that is perfect. That's exactly what we were trying to do. So we've accomplished our goal. Now we'll add the y's. Positive 1y minus 6y gives us -5y. Positive z minus 2z gives us minus 1z, or just minus z. And then -4 plus -2 gives us -6. Now this is still an equation with two variables, but it's a new equation, not one of the original three. So I like to name this equation number 4. And now I have one equation with two variables. If I had another equation with two variables, the y and the z, then I could use those and using addition or elimination method, get rid of yet another variable. And that's our goal right now, is to do that exact same thing and find equation number 5. So looking back here, we're still getting rid of x. And since I used a combination of equations 1 and 2, I need to use a different combination. I can use equation 1 and 3 or 2 and 3. 1 and 3, they both have variable or coefficients out in front, 2 and 3. So to make them match with the lowest common multiple, I'll need to multiply both equations. So I'm going to go ahead and take equation number 2 again, because it has a 1, and that's always convenient on these. And I need to multiply it by something to make it match the coefficient in front of equation 3. So if I take equation number 2 and multiply it by 3, then the coefficients in front of the x's will match, and if one is positive and one is negative, they will cancel when I add them together. So I'm going to go ahead and change this to a negative 3 so that they will have one positive and one negative. That way, when I add them, they'll cancel out. So using the distributive property, like we did before, negative 3 times the first term gives me negative 3x. This is the first term here. Then I need negative 3 times the second term, giving me negative 9y. Negative 3 times the third term gives me minus 3z. And again, don't forget, we need to multiply the right side of the equation as well. And negative 3 times 1 is negative 3. Now the next thing we're going to do is just take equation number 3 as it is. We don't need to change anything because those coefficients will now match. 3x minus 2y plus 4z equals negative 23. And we will add these together using the addition or elimination method. Negative 3x plus 3x cancels, so we have accomplished our goal of getting rid of the x yet again. Negative 9y minus 2y is negative 11y. Negative 3z plus 4z is 1z, and we can put the 1 out in front, but I think it's kind of messy, so I just leave it as a z. And negative 3 minus 23 gives us negative 26. Again, we have another new equation, so I'm going to label this as equation number 5. Now we have two equations with just two variables, the two matching variables, y and z on both of them. The reason we did that was now that I have them as two equations with two matching variables, I can get rid of yet another variable. And that's why we did a combination to find equations 4 and 5 from our original 3 to get rid of the x, or any variable for that matter. But that's why we did this right here, making sure we get rid of the x twice so that we are left with the two equations. Now we're going to come over here and I'm going to look at equations 4 and 5. Equation 4 is negative 5y minus z equals negative 6. Equation 5 is negative 11y plus z equals negative 26. And now I want to look and see of what variable I can get rid of again, so I'm only left with one. Looking at the first one, we have negative 5 and the second is negative 11. That gets kind of messy to make those match. To multiply both equations, I would need to multiply to get the lowest common multiple of 55, the first equation by 11, and the second equation by 5. So that gets kind of messy. But I can look at the z's and see that they both have a 1. They even match for us already. So I don't need to multiply anything, including I have one negative and one positive. So I can just go through and add those together as they are, and they will cancel out. So I don't need to do anything, and that was really convenient. So we'll add these together, and I get negative 5y minus 11y gives me negative 16y. And on the right side, negative 6 minus 26 is a negative 32. I'm down to one variable now. To solve for y, we just divide both sides by negative 16. Negative 16 divided by negative 16 cancels, leaving us with y equals a positive 2. And we have our first coordinate for our ordered triple. It goes in the order of x, y, and z, and we just found the middle coordinate, which is 2. So we'll fill that in. It might sound a little daunting that we went through so much work just to get one coordinate, but the next ones come much faster. So now that I have the coordinate for 2, I can go back and plug it back into one of the two equations with just two variables. So either equation 4 or 5. And it doesn't matter. We can pick either one. I usually pick the smallest, so I'm going to use equation number 4 because I find that I make fewer calculation errors if I pick one of the smaller ones. So I'm going to go through and we get negative 5 times y, so we'll substitute the y in with parentheses, minus z equals negative 6. Negative 5 times 2 is negative 10, minus z equals negative 6, and to solve for z, we'll add 10 to both sides. Positive 10 or negative 10 plus 10 cancels, and negative 6 plus 10 gives us positive 4. So we have negative z equals positive 4, and to continue solving, we'll divide both sides by negative 1, making this z equals positive 4 divided by negative 1 is negative 4. And now we have our second coordinate that we found for our ordered triple, which is the z negative 4. So it was much faster. Now that we have two coordinates, we can go back to any of the first to find our last coordinate. So equations 1, 2, or 3 have all three variables, and when I substitute two of them in, that just leaves me one left. Which one looks the smallest? I'm going to go ahead and go with equation number 1. So I'm going to write equation 1 here, which is 2 times x. We don't have the x yet. We're looking for that. We'll substitute the y in, which is positive 2, and substitute the z in, so plus negative 4, and this equals negative 4. So now we can combine like terms. Positive 2 minus 4 is negative 2. So you have 2x minus 2 equals negative 4. And to keep solving for x, we'll add 2 to both sides, which leaves us 2x equals negative 2. And then our final step will be divide both sides by 2, which leaves us with x equals negative 1. And now we've found the last coordinate to our ordered triple, which is negative 1. And we are completely solved for our system of three variables. And we're all done.